system, and what does it do? Well, a system, as you might already know, is a group of organs that work together in your body, and the endocrine system is a system of the body that's made up of endocrine glands. Basically, endocrine glands are glands that function to release their secretory products or hormones directly into the bloodstream, rather than via a duct, as is the case with exocrine glands. These diagrams here of the male and female body will feature throughout this tutorial, where we can see the body from the front with the endocrine system drawn over the external surface. We'll use these illustrations as we work through the components of the endocrine system, starting from the top and working our way downwards. So first we'll discuss the pineal gland, which is this tiny structure you can see just here. Then we'll talk about the hypothalamus, which is unfortunately not visible in this image, but don't worry because we'll see it later on in the tutorial. Just below the pineal gland we can see the pituitary gland here, then in the neck region we have the thyroid gland here. Next we'll talk about this gland here, which is called the thymus, followed by the suprarenal glands, which we can see just above the kidneys. We'll then talk about the pancreas, which we can see here, and finally we'll move on to the aspect of the endocrine system that varies between females and males, the ovaries and the testes. We can see these structures in the pelvic region here and here. Keep in mind that although the endocrine glands secrete the hormones they produce into the bloodstream, the thyroid gland stores its hormone extracellularly as an inactive precursor molecule. So now that I've given you a quick overview of what we're going to talk about today, let's get started. As I said, we'll begin this tutorial with the pineal gland, which is also known as the epiphysis cerebri. The pineal gland is located deep within the brain in the posterior cranial fossa. This small pinecone-shaped gland plays a very significant role in the human sleep-wake cycle. Our sleep-wake cycle usually mimics the rhythm of light and darkness. This means that when it's dark out we feel sleepy, as opposed to when it's light out where we are more awake or alert. Now the pineal gland, seen here from a mid-sagittal section of the brain, releases a hormone that alters the state of wakefulness and sleep. Although it's a really tiny structure, this gland releases a hormone called melatonin and regulates the circadian rhythm. The circadian rhythm is just a fancier clinical way of saying the sleep-wake cycle. Another structure we can see in the illustration of the mid-sagittal section of the brain is the hypothalamus. The hypothalamus is an area of the brain that consists of a number of small nuclei, and we can see it here highlighted in green. It's at the centre of a variety of physiological processes, including thermoregulation, osmoregulation, and hormonal regulation, which is relevant to the endocrine system. The hypothalamus works closely with the pituitary gland to modulate endocrine activity based on the body's physiological demands. So we just saw that the hypothalamus works closely with the pituitary gland. The pituitary gland is also known as the hypophysis cerebri. This small pea-shaped gland is situated at the base of the brain in the middle cranial fossa. The pituitary gland is what you can think of as a governor or traffic controller, because it's responsible for regulating some major glands that release hormones that are integral to growth and development. It regulates structures including the adrenal glands, the thyroid gland, the liver, the mammary glands, the ovaries and the testes, by releasing hormones that specifically target these organs and glands to stimulate them. Now I want to show you the pituitary gland from a different perspective here, with a mid-sagittal cross-section of the brain, where you can clearly see the gland highlighted in green. The pituitary gland has an anterior part known as the adenohypophysis, which releases follicle-stimulating hormone, luteinizing hormone and prolactin. It also releases growth hormone, thyroid-stimulating hormone, and finally adrenocorticotrophic hormone. The pituitary gland also has a posterior part known as the neurohypophysis, which releases antidiuretic hormone and oxytocin. These two parts have different functions, but the gland as a whole is connected to the hypothalamus via the infundibular stalk. Let's go back to the image of the endocrine system, where we can now see the thyroid gland, which is situated here, anterior and inferior to the larynx. It's comprised of two lobes which are connected via an isthmus. An isthmus is essentially a narrow anatomical part or passage connecting two larger structures. So here we can see the two lobes, and between them we have the isthmus. The thyroid gland produces a hormone called calcitonin, and two other hormones that help regulate the basal metabolic rate of cells, which are called thyroxine and triiodothyronine. Situated behind the thyroid are 4 small glands called the parathyroid glands. These glands, which are not seen here in our illustration, release a hormone called parathyroid hormone, which is responsible for regulating blood calcium levels. Located in the anterior mediastinum is the next endocrine gland we're going to talk about, the thymus. The thymus, which we can see here highlighted in green, is bilobed and surrounded by a connective tissue capsule. The thymus itself is comprised of an outer cortex and an inner medulla. It's a primary lymphoid organ and the site for T-cell maturation, and as an endocrine organ, the thymus produces a hormone called thymosin that stimulates the production of antibodies. Superior to the kidneys lie 2 major endocrine organs referred to as the suprarenal glands or the adrenal glands. These glands are pyramidal in shape and are comprised of 2 layers, the outer adrenal cortex and the inner medulla. Both glands are surrounded by a fatty capsule. In the next illustration, we can see the right suprarenal gland superior to the right kidney. The adrenal glands release a number of hormones, including mineralocorticoids, weak androgens, glucocorticoids, and the catecholamines epinephrine and norepinephrine. These glands are one of the glands whose activity is regulated by the pituitary gland. Another important organ with endocrine function is the pancreas. The pancreas is situated in the retroperitoneum, with the exception of its tail, which is intraperitoneal, and is an accessory organ of the gastrointestinal tract. The pancreas carries out other functions, but its endocrine functions come from the pancreatic islets or the islets of Langerhans, which are endocrine cells found within the pancreas. These cells produce several hormones, including glucagon, which increases blood glucose levels and is produced by the alpha cells, insulin, which decreases blood glucose levels and is produced by the beta cells, and somatostatin, which is produced by the delta cells and inhibits the release of growth hormone and thyroid-stimulating hormone by the pituitary gland. It also inhibits the release of hydrochloric acid from the gastric parietal cells of the stomach. Now we'll briefly discuss the endocrine organ responsible for the secretion of sex hormones. First, let's mention the ovaries, which are not only responsible for female gametogenesis, but also function as endocrine glands. They are almond-shaped structures found on either side of the uterus, and they're covered on the surface by a simple cuboidal epithelium. Besides containing the female gametes or ova, the ovaries also produce 2 female sex hormones, estrogen and progesterone. But keep in mind that it's the pituitary gland which controls ovulation, through the secretion of follicle-stimulating hormone and luteinizing hormone. Analogous to the ovaries in females are the male gonads, which are the testes or the testicles. Aside from their role in the production of spermatozoa, they also have endocrine function. The testes, which hang in suspension attached to the spermatic cord and are housed in the scrotum, also produce the male sex hormone testosterone. We've seen that endocrine glands play a significant role in the release of different hormones essential for growth and development. The complex mechanism that regulates when, where, how, and how much of a hormone is released is vital to the proper development of the body. When this doesn't work right, it can lead to different disorders depending on the organ involved. We'll look at an example of this in our clinical notes. So in the image on the right, we can see a condition commonly known as goiter. This condition, in which the thyroid gland swells or is enlarged, forming a visible lump at the front of the neck, can be caused by a number of factors. Iodine deficiency accounts for up to 90% of cases worldwide, but other causes include hyperthyroidism or an overactive thyroid, hypothyroidism or an underactive thyroid, inflammation of the thyroid, and even thyroid cancer. Depending on the cause, goiter can be treated with either medication, such as iodine supplements, with hormone therapy, or surgically where the patient has their thyroid gland removed. This surgery is known as a thyroidectomy.